This puzzle is called Jingle Bells by Infinity Gamers 00. I got it from the Sudoku testing submissions channel of the CTC community Discord. Let's take a look at the rules. So the first, and looks like the major rule, is the alternating parity line. Basically what that means is that digits along these lines will alternate from even to odd, back and forth for the whole thing. So let's say this was a 5, then this digit would have to be an even, these digits would have to be even, and then the next digits would have to be odd, and so on and so on. All the way around, all the way around and looping back on itself. And red, I think, acts the same way. Let's say even, odd, even, odd. Even, odd, even, odd. Yeah, I said it even at the first, and yeah, so this is, I think the redness versus the yellowness is just thematics, of course, because this is like a Christmas bell. But it just works the same way. Okay. Crop key dots. Digits separated by a white dot must have the difference shown in the circle. So if this was a 5, this must be a 4 or a 6 because it has a difference of 1. Whereas, I guess we can just do this 5 1. This digit must have a difference of 5, so if we discover this was a 3, this would have to be an 8. Okay? And then the killer cages, the digits add up to the number given in the top left corner. So yeah, these two digits add to 12, so if this was a 4, this would have to be an 8 in order to add to 12. But there's several options to add to 12 and even more to add to 25. I think that's all the rules. I'll put a link to the puzzle down in the description. Let's give it a go. The first thing I see is this digit right here. We can determine this value. So the full 3x3 box is going to add up to 45. That's because it contains the digits 1 through 9 exactly once each. If you add up the digits 1 through 9, you get 45. And that logic holds the same for rows and for columns as well. Each one of those, each full set of the digits 1 to 9, add up to 45. So this 3x3, that's up to 45. Then we have 25 here, so that's 20 left. Minus 12 is 8. Let me just double check that math. I think that's right. 12 plus 8 is 20, plus 25 is 40. Yeah, that seems reasonable. We actually have this same 15 and 12 cage along both of these sides. So this is going to be both of these triples are going to add up to 8. So there'll be a 1 in each of these. There's only 2 ways of making 8 and 3 digits. You can either do 1, 3, 4 or 1, 2, 5. So as far as I can tell, they could either be either of them can be either of the values. And I don't even think they affect each other necessarily. Actually, you know what? That's not quite true. Oh no, it is true, but there's some specifics to that. Let's actually take a look at the parity here. We don't know which, or at least I don't know where to start necessarily. Let's just start right here, I guess, and we'll just start coloring these and see how it goes. Let's do dark green and dark pink because that's Christmassy. So we want to do dark green, and we'll need to skip uh, every other cell. See, then these corners would also be dark green, and then these would be pink. I think that's right. Adjacent digits along every line should be the opposite colors. I think that's all good. I think that's all good. Now, one thing that's a little tricky, of course, there's 5 even numbers and 4, there's 5 odd numbers and 4 even numbers. We don't know which is which. We can definitely start making some deductions. For example, whatever this parity is, adding 1 to it will give us the opposite parity. So if this was a 3, this would be a 2 or a 4, so it goes from odd to even. And obviously, similarly, if this was a 5, if this was a 5, this would be that's the same way I did it. It always switches parity is basically what I'm saying. When you add 1 or subtract 1, it either goes from odd to even or even to odd. So we can use these 1s like this and just fill in the next one. This one must be opposite. Then the 2 must be the same, so like 4 plus 2 is 6 and stays even, or 3 plus 2 is 5, stays even. This one, uh, adding 5 will swap it, so, like, let's go from 3 to 8. It switches from even to odd, or odd to even. Same for that. Oh, I missed this one up here. Okay. Uh, so this is gonna be one of each. Yeah, I think we're gonna have to do something a little advanced. Not super advanced, but think about this without just straight coloring. At least as far as I can tell right now. So, yeah. Um, hmm. So both of these are going to be oh, no, never mind. I thought there were 5 pinks along this row, but there's not. So anyway, both of these are going to be the same parity. Either both odd or both even. Because they're divided by a 2. These two cells are going to be the opposite of whatever these two cells are. Which doesn't actually help us at all. So we'll end up with 4 greens and 4 pinks in these 8 cells. And this can be a blue or a pink, and that doesn't matter. Okay, maybe not the place to look. I thought I was onto something there once I started taking so many cells. Okay, here's something. No, maybe not quite. Uh, no, that's not. Oh, yeah. I can't quite figure out where to look. So right here, there's these two. So both of these twos, actually, I was thinking that they couldn't both be the same thing, but they could both be pink, which would make this green, and then one of these are greens or pinks. Is there maybe a column that I'm not noticing is more restricted than it is? So we have 4 greens in this column, so if greens were even, these would both be pinks. Doesn't seem to be a problem. Oh, here's something that I missed. This 12 gauge. Because it adds up to an even, you either add 2 odds to be an even or 2 evens to be an even. So basically, the parity is going to stay the same between the 2 numbers being added. Oh, and there we go. That's what I missed. That's the key. So now we have 4 pinks in this box, and we need to put another pink in here because it's divided by 1. So therefore, pinks are odds. So this is not 1. This is not 1. Um, yeah, pinks are odds, and then this must be green. 1, 2, 3, and then the 4th one down here. Yeah. So this must be no. This could be 3, 5, 7, or 9. Yeah. Do we start numbering or does? I guess we can look at this. So when I said there were 2 different options for 8 triples that add to 8, and it does help a little bit. And this is 7 or 9. If we add 5 to that, it does help a little bit. So this is either 1, 3, 4, or 1, 3, 4 with the 1 at the bottom, or it's 1, 2, 5 with the 2 in the middle. And same for this side over here, but of course they're going to be different because of uh, the 2 4 see each other. The 12 cage must have a 1 in it, and we have an X swing on 1s. What that means is, let's just delete all the colors for just a second. So we have what's called an X swing on 1s here. What color shall I use? I'll use hot pink. Now, in the final, once we finish the puzzle, there's either going to be a 1 here and a 1 here, because this 1 rules the 1 out from being here, so it must be down here. Or it's going to be a 1 here and a 1 here. Those are the only 2 options. And we know that because those are the only 2 options for 1 in this whole row. Or sorry, in this whole column. So if we look at it, we can't put a 1 in any cells along here. Because if we tried to put a 1 in here, okay, right here, because you can't put a 1 in a 12 box anyway, but if we tried to put a 1 right here, let's say, this couldn't be a 1, this couldn't be a 1, so we'd have to put a 1 here, and we'd have to put a 1 here, and the puzzle would be broken, because we'd have 2 1s in the same row. So what that boils down to is we can't have 1s along here or along here, But we need a 1 in the 12 cage to add up to 12. If you don't use a 1, 2, 3, whoops, 2, 3, 4, 5 adds up to 14. So 12 in 4 needs a 1, so that's a 1. Long story short, I guess. This is 6, 7, 8, 9 over here because we have a 1, 3, 5 triple. So this has a 7 or 9 as the odd digit, and that connects to a 6 or an 8. And in fact, no, never mind. I was going to say this couldn't be a 7 or 9 because of this, but that's not necessarily true. This is a 2, this is a 3, this is a 9. This would have a 7. This is a 2, this is a 4, this is a 9. So these two are probably the same digit, actually. Or could be the same digit. 4, I guess, can go to either one of these. Yeah, I don't know. I think there's too many. I don't think we can just figure out an easy way of differentiating. So right here, I just noticed we have a 5 crappy dot here, so this must be the opposite of this, so yeah, we can switch that over here. Um, let's see. Can we figure out what this is? Or, I don't know if we can well, this must be an even digit. Does that help at all to mark? And this must be some odd digit. Yeah, I don't know if that actually helps to mark. I was thinking we could reduce some options, but even this one, I guess it's not 5. That's the only restriction on that cell, is that it's not 5, because 5 plus 5 or 5 minus 5 is 0 and 10, which is an even number, but not an even number that's allowed to be in the puzzle. Okay. Oh, we know this must be... Okay, so I talked about this earlier. So currently we have 2 greens, 2 pinks. Both of these will be the same. Whatever color this is either both be greens or both be pinks. These will both be the same, but the opposite of the ones we just did in this 2 pair. So that means in these 8 cells, we have 4 greens, 4 pinks, and some configuration. We can't put any more greens in the box, so we need to put pink in the box. 1, 2, 3, 4. And we have 4, in this column we have 4 pinks, 4 greens, so this must be a pink. This must be a green, this must be a green, because the 1 crappy dot means we swap, the 2 crappy dot means we stay the same. These both must be pink, and actually both of these must be pink because we already have 4 greens in the box. Okay, here's something. So one of these two is going to be green. And if we look at the row, that will be the last green for the row. These are both different. So that's the 4th green for the row, so this must be pink. Which then we can kind of backfill and realize, okay, adjacent to the pink must be green because the 5 swaps it, and then that becomes the pink, and then this becomes a pink because of the 2, and that's green because that's all that's remaining. Okay, so here in box 7, we have 3 greens already, and there's going to be 1 green in this bottom domino, this bottom pair here, because it's separated by a 1. So now we have the 4 greens accounted for, so both of these are pink. No, I don't think we can do anything there. Oh, I guess we know that 1 is odd and blue is pink, or 1 is odd. I didn't even do the right color. My head is a little spinny today, I guess. I literally just said blue is pink, and that's just nonsense. So, pink is odd, green is even. Oh, this can't be an 8, so this can't be a 9. Okay. Um, let's see, how do we... Okay, yeah, so we have 4 pinks in the bottom row. One of these is going to be a pink because it's separated by a 1. We don't know which is which, but we know one of them is a pink, so this can't be a pink. Now I have 1, 2, 3, 4, 5 pinks in this row, so this is green. Which makes this green because of the 2, makes this pink because of the 1, and this is going to be pink as well. Okay, let's look at... Well, I guess we can... These two both must be green. because the 1 and the 5 both mean we swap. So one of these is going to be pink, one of these is going to be green because of the 1. That leaves, we need 1 more pink in the box because we need 5 pinks, so this is a pink. And then the 12 cage must both be the same parity, either both odds or both evens. Then we have this here. Oh, we can do top row. I missed up here the bow on the top of the bell threw me off. I think this must be a green. Yeah, that looks right. And now we have 4 greens in the column, so these must be pinks. Wait, 1, 2, 3, 4, 5. So this must be green. This must be pink. So this can't be a 7. This can't be a 6. Which means this is a 3 or a 5. This is a 7 or a 9 because this 12 cage must be both odds, and so it has to be 3, 5, 7, 9. But we have a 7, 9 pair looking over. So this is a green and this is a 6 because that's just the last digit left in the row. Oh, we have all the evens in this row, so we can say both of these are odds. Then to finish out the box, both of these are evens. For column 6, we already have 5 odds, so this is an even, and this must be an odd. Oh, I forgot this. This must be an even as well. This must be an even. Okay, there we go. I think that's all of it that I see. Okay. So this must be a 6, 7. This must be a 6 or an 8. Yeah, because it's. So these are. Feel like something's going on here. But I can't quite figure out what it is. These two are opposites. Yeah, okay, so this 7, 9. This 7, 9 is the opposite of this 7, 9. If we put a 7 here, this would have to be a 9 here. Because they see each other in the row. Then these two are the opposites, also, because they see each other in the box. That means this 7, 9 and this 7, 9 are the same. But they connect to different evens. Which means if we tried to put 9 here, then these would both be 8s and break the puzzle. So this cell can't be 9, it must be 7, which then is going to give us a lot of useful information. 2 must go with 3, which goes with 9. These can't be 3s, these can't be 5s. I think we're good. Yeah, this is 2, 6, 8. This is 4, 6, 8. 4 would go with 9, 6 would go with 1, 8 would go with 3. None of those cause a problem that I see. Yeah. Unfortunately, 1s can go either lower or higher, so it's it's a bit restricted. Actually, it's only 5 or 7 now that I think about it, because 8 can't go up to 9 because the 9 in the column, and 4 can't go down to 3, so they must kind of go inwards. Then this one is going to be 4, 6, 8 again. It's not necessarily the same as this digit, of course, because they can, like this could be 6, 7, 8, something like that, but okay. Well, this can't be a 2. If this was a 2, this would have to be a 7, and we already have a 7 in the column, which means this is a 2 and this is a 1 or a 3, and then this is also a 1 or a 3, which means this can't be a 1 or a 3, so that must be a 9, which must go with the 4. So this is a 5 or a 7 as well. These two must be 2, 4, and this is a 3 or a 5. Okay. Okay, so this is a 2, 4, or a 6. It can't be 6, 8, or it can't even have an 8 on it because 8 would go with 6, which would then break this cell because we couldn't fill it. So this must either be 2, 4 or 4, 6. On this cell actually can't be a 6 because it can't connect to a 5 or a 7. This cell must be 1, 3, or 5, and it can't be a 5. So we have a 1, 3 pair in the column. This must be a 9, so this must be a 7. The last remaining one must be the 5. This is a 4 or 6. This is a 2. Oh, this can just be anything. I guess it can't be a 4 because we have the 4 already in the column, designated down here in box 9. So this is 2, 6, or 8. If this is a 6, this is a 6. This is an 8. Yeah, that's fine. That's fine. Okay. Where to look now? This is a 1 or a 3 because we already have, whoops, 5, 7, and 9 looking at it from various angles. This is a 1, 3, or 5. This is a 6 or an 8, which makes a 6, 8 pair in the column, which is this is just 2 or 4. So then this is 2, 4, or 6. I don't know. Yep, I mean, that seems reasonable. I don't know why I said I don't know. This is a theoretically 5, 7, or 9. Can't be 9 because of the 9 in the row. Can't be, or sorry, 9 in the box. Can't be a 5 because of the 5 in the row. This must be 7. This must be 5. This must be 6. This can't be an 8 any longer. So this must be an 8. This must be a 3. And this, oh, can't be a 5, so that must be a 1. Oh, this 5 is looking over, so this is a 7. Oh, 1 in this row can't go in column 6 because of this, so this is a 1, this was a 9. This is a 3, 5. Yep, sure. That looks good. This is a 2, 4. No, this is a 4 or 6. We actually have a 2 looking up, which makes this the 2. Missed that earlier, which makes this a 4. Yeah, I think that's all reasonable. This is a 2, 6, or 8. I don't know if I want to... Oh yeah, 2, 6, or 8. Yeah, because this actually can't be an 8. Because if we tried to put an 8 here, this would have to be a 7 or a 9. Which neither of those work. And probably the best way to look at that, it makes that an 8. But the best way to look at this is what's the odd left in the column, I think. So this is just a 5. This is a 6. This is a 2. This is an 8. So this is a 3 because it's 5 away from 8. This 6 is looking over and remove 6 as an option from there. So now we have a 2, 4 pair. That can't be a 2 any longer. These are 6, 8. This 8 looks over and disambiguates that immediately. Which makes this a 4. This has to be a 6. This has to be an 8. This is 3, 1 then. Because the 5 dot figures that out. This must be a 1 because of the 3, which is going to figure a lot of stuff out. This is a 3 or a 5, but the 3 is looking over, makes that a 5, which makes that a 3. This is 7, 9 remaining, and okay, we're out of luck there. This is 2 or 8, and there's a 2 looking over, so this is a 2, this is an 8. Now this is a 4 or a 6. Oh, this is a freebie. This is a 2. This is 4, 6, 8 left in the row. This can't be a 6 because of the 6 here. These are 1 and 7, just the odd digits left, or all the digits left in the column, which makes this a 9, which is gonna figure that out. This must be an 8 then. This can't be an 8. So this is the last spot for an 8 in the row. Oh no, we already have the middle 8, okay. That must be a 6 because that's the last even in the row, so this is a 4, this is a 6. This is a 4, this is a 6. This 4 looks down. This must be a 2 because we have 2's looking down. And actually we have 2's looking over to the side, but I just saw that this was the only green in the column in this box. Okay, what do we have left in this column? We have 3, 5, and 7. And we have 3 and 5 in row 8. So this must be a 7. Where's that 7? This can't be a 7. So this is a 135 triple, so this is 7-9, but this 7, of course, sets that right away. Then this must be a 9, because we have a 9 here and a 9 here. This is the last spot in the box. This is a 1, because it's the last digit here. This is a 4, last digit in the row. What is this, 3, 5? Okay, what am I missing here? What am I missing here? Oh, of course, the 12 cages is the very first thing I looked at. 1, 2, 4 is 7. This needs to be a 5. Okay. Yeah. I like when the very last clue is the same as the very first clue you look at. It's always a nice little, I don't know, a nice ending that I appreciate. That was a lot of fun and very Christmassy. Um, yeah, this looks great. Let's remove the color just for a second so we can see the bell again more clearly. I was probably like 1.5 out of 5, maybe a 2 out of 5, but probably a little bit easier than that, I think. But it was a lot of fun, and as I said, great theming for this time of the year. Thank you, Infinity Gamers, for the puzzle, and thank you all for watching.